Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 11th, and the chapter that we're dealing with is Conic sections. It is time to deal with exercise number 11.4 now, and exercise number 11.4 is based on the topic hyperbola. The standard equations of hyperbola and some things related to that, that's foci, vertices, transverse axis, conjugate axis, some of those things, lattice rectum will be found over here, right? And along with the questions, we'll also discuss the concepts of this particular topic, right? So without wasting any further time, let's continue with the first question over here. The question says, in each of the exercises 1 to 6, find the coordinates of the foci and the vertices, okay, the eccentricity and the length of the lattice rectum of the hyperbolas, okay. Coordinates of the foci and the vertices, those are the two things, and eccentricity and length of lattice rectum. A total of 4 things have to be found over here. Let's see. This particular hyperbola is a standard hyperbola, right? And which kind of a standard hyperbola is this? Let's take a look at the diagram and the concepts associated with that, okay. Since you can observe that the coefficient of x square is positive, this is equal to 1 and the coefficient of x square is positive, therefore this will be the hyperbola that you'll have over here along the x-axis. The transverse axis will lie along the x-axis. This is what you have. This is the origin, which is also the center of hyperbola, and this is what you have. These are the vertices. The coordinates of the vertices will be a, comma, 0, and this will be minus a, comma, 0. The foci will be here, c, comma, 0, and similarly minus c, comma, 0 over here. This will be the foci. This here is the conjugate axis, this here is the transverse axis, this here is the conjugate axis. Lattice rectum is this particular line over here, which is perpendicular to the transverse axis and passing to the focus, this particular line segment, right, having its edge points on the hyperbola. So length of lattice rectum over here is 2b square upon a. This formula is similar to the one we saw in ellipse. Ellipse also has a similar formula for lattice rectum. There a square and b square are again found in the equation of ellipse, and lattice rectum will be 2b square upon a. That's what you have, right? What else? One more thing, that is eccentricity is equal to c upon a over here. This is c and this is a. So eccentricity is always greater than equal to 1 since c is greater than equal to a. That's what you can observe over here. There is a special case when eccentricity is equal to root 2, and that occurs for a equals b. In that case, eccentricity becomes root 2 and the hyperbola is called an equilateral hyperbola in that case, right? Those are some special things related to this. And once we observe this much, then we can deal with this particular question over here, comparing with that diagram, right? So since the coefficient of x square is positive, the hyperbola will be this. That's the first thing that you'll observe. This point is a, this point is c. Similarly, you will have minus a and minus c over here, right? And we can observe that the denominator of x square will be a square. So a is equal to 4, b as you can see will be equal to 3, and with the help of this you can find c square. C square is equal to a square plus b square over here. C square is equal to a square plus b square, and what does that become? This is 16 plus 9, so c will be equal to under root of 25, which is 5. C is positive, mind you. I am not taking plus or minus 25 under root 25. I am taking simply plus 5 because C as such is positive. This will be minus C, that will be minus 5, right? So the value of C has been found. The values of A and B are already given in the question, and now I can write the coordinates of foci. Foci will be C comma 0 or minus C comma 0, which is plus or minus C comma 0. These will be the coordinates of foci. What about vertices? Vertices will be a comma 0 or minus a comma 0. You can see plus or minus a comma 0. These will be the coordinates of foci and vertices, right? Eccentricity and length of lattice rectum. Eccentricity is c upon a, which is equal to c upon a, which is 5 by 4. This is the eccentricity. That's the next thing. And length of lattice rectum, that is denoted by LR, and that is equal to 2b square upon a, which is equal to 2 times b square, 2 times 9 upon 4, 2 times 9 upon 4, which is 9 by 2. That's what you have. And yes, this, that's the final answer for this question over here, as you can see, with the help of all of these concepts, all of these ideas as discussed over here, right? That's the first question for us. Let's move on to the next one after this. In the second question, we have y square by 9 minus x square by 27 is equal to 1. And you may observe that the coefficient of y square is positive. Since the coefficient of y square is positive, right hand side has a 1. So the hyperbola will have transverse axis along the y-axis. Transverse axis will be along the y-axis in this manner. Right? This will be the hyperbola that will have, and this will be the transverse axis of the hyperbola. The foci will lie on this axis. These will be the vertices, right? Okay, and this will be 0 comma a, this will be 0 comma c, this will be 0 comma minus a, this will be 0 comma minus c. Those are the vertices and foci respectively. Okay, this is x-axis, this is y-axis, and what are we dealing with over here is y square upon a square minus x square upon b square is equal to 1. This is the hyperbola that we are dealing with, right? Latus rectum and eccentricity are pretty simple. Eccentricity is once again c by a. Latus rectum is 2b square upon a. This is latus rectum, right? Eccentricity is c upon a and latus rectum is 2b square upon a for this one. So once we are through with all of that information, then we can deal with this particular question. We can say, okay, here also we have transverse axis along the y-axis, since the coefficient of y square is positive, right? And this here is a, this here is c. That's what we observe, right? This here is a, this here is c. And what else? What else? From the equation directly, I can observe that the denominator of y square is actually a square. So a square equal to 9 implies a equals 3. B square is equal to 27 implies b is equal to under root of 27. Under root of 27 will be 3 root 3. That's what you have, right? This is the standard form of hyperbola and this is what you have. What else? With the help of a and b, I can easily find the value of c. C is equal to a square plus b square and its under root. What is that equal to? A square plus b square is 36 under root, which is 6, right? We can directly add these and take the under root. That's what you get. C equals 6. Okay, with the help of these few things, can you easily find the foci? Write the coordinates of foci. Foci will be 0 comma c, 0 comma minus c. As you can see, 0 comma c, 0 comma minus c, which will be 0 comma plus or minus c, which is 6. Vertices. Let's take a look at the vertices. Vertices will be 0 comma a, 0 comma minus a, as over here this will be 0 comma plus or minus a, which is 3. So foci and vertices have been found. What next? Eccentricity is equal to c upon a, which is 6 upon 3, which tells me E will be equal to 2. What about latus rectum? The length of latus rectum will be equal to 2b square upon a, and that can be represented 2 times b square, which is 27, upon a, which is 3. This is equal to 18, and yes, that gives me the final answer. This and this are asked in this question, and we have found all of those things over here. That's the complete solution for this hyperbola, as we can say. The next question says you have 9y square minus 4x square equals 36. Okay, this is not written in the standard form. Let's rearrange first of all. So we'll divide by this 36, make this 1. So what you'll get is y square upon 4 minus x square upon 9 is equal to 1. Okay, and this particular hyperbola has this transverse axis along the y-axis. This is the hyperbola that we are looking at. Okay, and what else? This will be the vertex 0 comma a, this will be the vertex 0 comma minus a, this will be the focus 0 comma c, this will be the other focus 0 comma minus c, right? This is x-axis, this is y-axis, this is the center, or you can call it the origin. This is the origin, or it is the center as well of the hyperbola, right? That's what you have. What else? With the equation, from the equation by comparison to the standard form is y square upon a square minus x square upon b square equal to 1. And this is a diagram for that. You can easily identify a equals 2. Since a square is 4, a equals 2. B square is equal to 9, b equals 3, and with the help of this, c is equal to under root of a square plus b square. Now what is that? A square plus b square is 13. 13 under root is the value of c. And once we have found all of these things, the coordinate of foci, very simple. Foci will be foci will be plus 0 comma c, 0 comma minus c, that's what you can say, 0 comma plus or minus c. This is root 13, right? These will be the coordinates of foci. What about coordinates of vertices? Can you observe that the vertices will be 0 comma a and 0 comma minus a. So vertices will be 0 comma plus or minus a. And what's the value of a? 2. Those are the coordinates of vertices. What about eccentricity? Eccentricity is c upon a. So that will be equal to root 13 upon 2. And lattice rectum is 2b square upon a, which is equal to 2 times b square, which is 9, upon a, which is 2, and this gives me the value 9. This is the lattice rectum for this hyperbola. Those are the few things that we wanted to find in this particular question. The next question has 16x square minus 9y square is equal to 576. Okay, so we'll have to divide by 576. Yes, precisely. We'll have to divide throughout by 576. And where does that take me? So we know that 16 times 9 is 144, and 144 times what is 576? Is it 144 times 4? Can you please check that? Yes. 144, 6 times 4 is 24. Yes, 144 times 4 is 576. So this will be x square upon 9 into 4, 36 is what I'll get over here, minus y square upon 16 into 4, 64 is what I'll get over here. This is equal to 1. This is the final equation of the hyperbola that we'll see. Okay, and since the coefficient of x square is positive, the transverse axis of the hyperbola will be along the x-axis. This vertex here will be a comma 0. This focus will be 0 c comma 0. Similarly, you'll have minus a comma 0 minus c comma 0 over here, right? This is the y-axis, this is the x-axis, this is the origin, which is also the center of hyperbola. And by comparison with the standard equation, we can simply say that the value of a is square root of this, which is 6, and value of b is obtained from here, which is 8. With the help of this, c is under root of a square plus b square. Under root of a square plus b square, which is 36 plus 64. What is that? 100. 100 under root is simply 10. Okay, you have found the values of a, b and c. That's the most important thing that you were supposed to find with the given equation, right? Once you find these values, the next thing that you want to do is you want to find the coordinates of foci. Foci will be c comma 0 minus c comma 0, which can be written as plus or minus c comma 0. Vertices, the coordinates of vertices, as you can see, a comma 0 minus a comma 0, which can be written as plus or minus a comma 0. Eccentricity, which is c upon a, is 10 upon 6, which becomes 5 upon 3. Lattice rectum is 2 times b square upon a, 2 times b square, which is 64, upon a, which is 6. Okay, this becomes 64 upon 3. And yes, that's the answer for this question, as you can see over here. That's the fourth question for us, and the values, the coordinates of foci, vertices, the value of eccentricity and length of lattice rectum have been found over here using standard equation, right? That's all that you have in this question. The fifth question says we have 5y square minus 9x square equals 36. Okay, divide by 36 and try to convert it into the standard form. First of all, dividing by 36, what do you get? This is y square upon, okay, 5 will not cancel with 36, so we'll have to write it as 36 upon 5 in the denominator, minus x square upon 4 equals 0. This is the form that you'll get, right? This is the standard form now. And since the coefficient of y square is positive, this will be a hyperbola which has transverse axis along the y-axis. Okay, this is the hyperbola that we are looking at. This point is the focus on positive y-axis. This is 0 comma c. This vertex 0 comma a. This other vertex will be 0 comma minus a. This other focus will be 0 comma minus c. This is the center, which is the origin, x-axis, y-axis. Now we can compare this hyperbola with the standard form, and we can say that a square is 36 upon 5, therefore a will be equal to 6 upon root 5. 6 upon root 5, that's what you can observe, taking the under root throughout. B is equal to, b square is equal to 4, therefore b is equal to 2. C is under root of C is under root of a square plus b square, under root of a square plus b square, which is 36 upon 5 plus 4. What is that? 56 upon 5, and it's under root. Now 56 can be written as 4 times 14, yes, 4 times 14. So that will be 2 root 14 upon root 5. This is the value of C that I'll be getting. Okay, and once I have the values of A, B and C, now I can easily write the coordinates of foci, the coordinates of vertices. Yes, foci, the coordinates will be, can you see, 0 comma C, 0 comma minus C. The coordinates will be 0 comma plus or minus C, which is this, 2 root of 14 by 5. That's what you have, right? Is that okay? Yes. This can further be written by rationalizing the denominator as 0 comma plus or minus, you will multiply it by root 5 in the numerator, root 5 in the denominator. So in the numerator you will have root 70 and 2 by 5 outside. This is what you will get by rationalizing the denominator, right? What about vertices? The coordinates of vertices can be obtained as 0 comma a, 0 comma minus a, which is 0 comma plus minus a, plus or minus 6 by root 5. You can leave as it is, or you can write it as 0 comma plus minus 6 upon 5 root 5 by rationalizing the denominator, that is multiplying divide by root 5. This is what you obtain. What next? Eccentricity is equal to C upon A, and that is equal to this upon this. Root 5 will get cancelled. 2 root 14 upon 6, or root 14 upon 3 is what I'll get for eccentricity. Lattice rectum is 2b square upon A, 2 times b square upon A, which is 6 by root 5. Okay, root 5 goes in the numerator, and this will be 3. So this becomes 4 by 3 root 5. That's the lattice rectum, and yes, those are the things that we wanted to find for this question as we have found over here. That's the 5th question. Yes. The 6th question says we have 49y square minus 16x square equals 784. Okay, so let's deal with this one. Okay, and where does that take me? So 49 times 16, is this close to 784 or somewhat? 16, 49. What you have is 50 times 16. 50 times 16 will be 800 minus 16. Okay, this is actually 49 into 16 only. So we divide by 784, and this tells me that y square upon 16 minus x square upon 49 is equal to 1. This is the form of standard form in which the equation is written now. Y square, the coefficient is positive, therefore the transverse axis of the hyperbola will lie along the y-axis. This is what you'll have. This point is 0 comma a, this point word focus is 0 comma c. Similarly, this is 0 comma minus a, and this is 0 comma minus c. Okay, from here the value of a will be 4, the value of b will be from here 7, and c is equal to under root of a square plus b square. What is that? Under root of this plus this, which is under root of 65. This is what I get. Once you have found the values of a, b and c, it is very easy to write the coordinates of foci and the vertices, right? So foci will be 0 comma c, 0 comma minus c, 0 comma plus or minus c, which is 0 comma plus or minus root 65. Vertices will be 0 comma a, 0 comma minus a, 0 comma plus or minus a, which is 0 comma plus or minus 4, right? What about eccentricity? Eccentricity is c upon a, which is c upon a root 65 upon 4. That's the value of eccentricity for us. Lattice rectum, as you can see, is 2b square upon a, which is 2 times b square, 49 upon a, which is 4, which is 49 upon 2. And yes, that's the complete answer for this particular question over here. The 7th question, okay, in this question, what does the person say? In each of the exercises 7 to 15, find the equations of the hyperbola satisfying the given conditions. Okay, so we are given the conditions and we are asked to find the equation of hyperbola. Pretty simple. Once again, first we identify which of these things, which of the standard hyperbola is this. So vertices along the x-axis and foci along the x-axis will tell me that transverse axis lie along the x-axis. And let's draw the diagram first. The first thing that we'll do is draw the diagram. So what do we have? Vertices at 2, 0. So this particular point will be 2, 0. Similarly, this particular point will be minus 2, 0. Focus at 3, 0 and minus 3, 0. This is what you'll have, right? Once you identify these few things, the equation of the hyperbola equation will look like x square by a square minus y square by b square is equal to 1. And the only things that you need to find after this are the values of a and b, or precisely a square and b square. Now, how do we find a square and b square? There are some conditions which are given, right? So, if you observe, this is a comma 0, so this is a equals 2 is given, c equals 3 is given, okay? And what about b square? So, c square is equal to a square plus b square tells me that b square is equal to c square minus a square. This is 9 minus 4, which is 5. So, b square is equal to 5. Okay, once you find this, therefore, equation of the hyperbola will become equation of hyperbola is x square upon a square minus y square upon b square, which is equal to 1. That's the final equation required for this particular hyperbola. That's all. Yes, that is all that you have over here. In the 8th question, we have vertices 0, plus minus 5 and foci at 0, plus minus 8. Okay. Now, these lie along the y-axis, so the transverse axis of the hyperbola will be along the y-axis in this manner. Right? Right. This will be 0, a. This will be 0, c. Okay. And equation will be y square upon a square minus x square upon b square is equal to 1. And with the given conditions, we identify that 0, 5 implies a will be equal to 5. From the vertex, you can see this, and c will be equal to 8. From the given conditions, we identify this. Once you have identified these few things, the only thing that remains for this particular hyperbola is a has already been found. The only thing that we need to find is b square, and there's a condition for that. C square is equal to a square plus b square. Therefore, b square is equal to a square, c square minus a square. What is that? C square is 64 minus 25. And where does that take me? This is 39, is it? Yes. 25 and 25 and 14. Yes, this is what you get. So, b square is equal to 39. Therefore, equation of hyperbola, required equation of hyperbola will be y square by a square minus x square by b square is equal to 1. This is what you have, and that's the final equation that is required for this particular question. In the 9th question, we have vertices and foci again given along the y-axis. Okay, they are given along the y-axis, so this will be a transverse. The transverse axis will be along the y-axis, and the standard hyperbola y square upon a square minus x square upon b square equal to 1 will be required. This is the required equation of the hyperbola. Vertices 0, a, foci, one of the focus is 0, c, not 0, a. One of the focus is 0, c. Right. Similar questions have been given over here, and from here I can identify with the help of given condition that a will be 3, c will be 5. Can I identify the value of b afterwards? Yes, b square is equal to c square minus a square. This tells me this is 25 minus 9, which is 16. Therefore, equation of hyperbola will be y square upon a square minus x square upon b square is equal to 1. This is the required equation of hyperbola, and that's my answer for this question, as you can see over here. In the 10th question, we have foci at plus minus 5, 0. The transverse axis is of length 8. Okay. Now we are given a different condition. Now how will we deal with this one? So foci at plus minus 5, 0 tells me they lie on the x-axis. So the transverse axis will be along the x-axis. For the hyperbola, the transverse axis will be along the x-axis, and this here will be the hyperbola. Okay, this point is a, 0. This point is c, 0. And similarly, you have minus a, 0, minus c, 0. The equation is x square by a square minus y square upon b square is equal to 1. What all is given other than that? Foci at plus minus 5 comma 0 tells me that C is equal to 5. But there's another condition also given. The transverse axis is of length 8. Transverse axis is from this point to this point. This is the transverse axis. So 2A is equal to 8, which tells me A equals 4. Okay. We needed A square, B square. We have obtained A, therefore A square. With the help of this C, we can obtain B square as well. B square is equal to C square minus A square. Or you remember C square is equal to A square plus B square, one and the same thing. It's 25 minus 16, which is 9. This is the value of B square. Therefore, equation of hyperbola becomes x square by A square y square upon B square is equal to 1. This is what you have, and that's the required answer for this particular question over here. In the 11th question, we have foci at 0 comma plus minus 13. The conjugate axis is of length 24. Okay, so how will we deal with this one, right? Foci at plus minus 13, 0 comma plus minus 13 implies that foci are lying on the y-axis. So foci on the y-axis implies that the y-axis will be the transverse axis. The x-axis will act as the conjugate axis over here. Transverse axis will be along the y-axis. This is 0 comma A, this is 0 comma C. This is 0 comma minus A, 0 comma minus C. Okay, and there will be some points over here which are denoted by B comma 0 minus B comma 0, and this length actually gives me the conjugate length of conjugate axis. Okay, the equation is y square upon A square minus x square upon B square is equal to 1. Okay, and from the given conditions, foci at plus minus 13 implies C will be equal to 13. That's one thing that is given. Conjugate axis is of length 24. Conjugate axis is this length 2B. 2B is equal to 24. Sorry, 2B is equal to 24 is given to us. These are two things which are given. So 2B equal to 24 implies B is equal to 12. We have found B, therefore B square. And do we know A square? No, not yet, but we can find A square with the help of B and C, as A square will be equal to C square minus B square. What is C square? This is 13 square. B square is 12 square, right? This is what you get. And this is 25 actually. 169 minus 144 is 25. Therefore, equation of hyperbola will be y square upon A square. Where is A square? This is 25 minus x square upon B square, which is 144, equals 1. This is what I have, and yes, that's the required answer for this particular question over here. This is 11th question for us, and that's the final solution for this. In the 12th question, what do we have? We have foci at plus minus 3 root 5 comma 0. The lattice rectum is of length 8. Okay, so let's use that. Foci at plus minus 3 root 5 tells me that the transverse axis will be along the x-axis. Okay, this is A comma 0, this is C comma 0, and similarly we'll have minus A comma 0 minus C comma 0. Equation will be x square by A square minus y square by B square equals 1. This is the equation of hyperbola, required hyperbola, and we are given that the foci lie at plus minus 3 root 5, therefore C will be equal to 3 root 5. That's one thing. But we needed A square and B square. For that we need two conditions at least. One of the conditions is this. The other condition is this. Lattice rectum. Lattice rectum is equal to length 8. Okay. So lattice rectum equals to 8 implies 2B square upon A is equal to 8, or B square is equal to 4A. This is one thing that we identify. One relation between A and B is this. What else? From C square is equal to A square plus B square implies that C square, what is this? 9 times 5 is 45 is equal to A square plus B square, which is 4A. Okay. So this is the other equation. Actually, we have substituted the value of B square over here to write 4A and get equation in terms of this. A square plus 4A minus 45 equals 0 tells me that you can factorize this. 9 times 5, 9A minus 5A minus 45 equals 0. Okay, and then you can factorize. A will come out common, A plus 9 will remain, and 5 minus 5 will come out common. A plus 9 is one of the factors. A minus 5 is the other one, equal 0. Tells me that A will be equal to 5 or minus 9. And which of these can you reject? The value of A is supposed to be positive. This can be rejected. So A is equal to 5 is the correct value. Once we see that A equals 5, can we also find the value of B square? Yes. A equals 5 implies B square will be equal to 4 times 5, which is 20. So this is B square for us. And once we have found A, therefore A square and B square, we can write the equation of hyperbola will be x square by A square, which is 25, minus y square upon B square, which is 20, equals 1. This is the required equation of the hyperbola. That's my answer for this question over here, this 12th question over here, right? In the 13th question, we are given that foci at plus minus 4, 0 and length of lattice rectum is 12. Okay. So similar kind of question, foci lie along the x-axis. So this will be, the transverse axis will be along the x-axis. Okay. This is A, 0. This here is C, 0. This is minus A, 0. This is minus C, 0. And the equation of this hyperbola is x square by A square minus y square by B square equals 1. This is the equation of hyperbola. With the given conditions, we can identify that C will be equal to 4 and lattice rectum is of length 12. Lattice rectum equals 12 implies 2B square upon A will be equal to 12. Okay, and from here you can identify that B square is equal to 6A. This is one of the relations between A and B. From here I also identify that C square is equal to A square plus B square, and this further tells me that A square plus B square is equal to 16. Okay, this is the other relation that we have. So equation 1 and equation 2. Can we find the values of A square and B square? Yes. B square can be replaced by 6A over here, and this can be factorized as 8 and 2, plus 8 and minus 2. So A will be equal to A plus 8 minus 8 comma 2. This is what you'll have, right? Minus 8 will be rejected, therefore A equals 2 and B square is equal to 6 times 2, which is 12. This is what I get. Once I have A, therefore A square and B square, therefore I can write the equation of hyperbola, which will be x square by A square minus y square by B square is equal to 1. This is the final equation of the hyperbola, and yes, that's the required answer for this particular question over here. In the 14th question, we have vertices at plus minus 7, 0 and eccentricity is equal to 4 by 3. Okay, and how do we deal with this one? Vertices at plus minus 7, 0 tells me that the transverse axis of the hyperbola will be along the x-axis. Okay, this is the most important thing. This is A, 0. This here is C, 0. Okay, similarly minus A, 0, minus C, 0. So the equation of hyperbola is x square by A square minus y square by B square is equal to 1. We need to find A and B somehow. What are we given? Vertices at plus minus 7, 0. Therefore A is equal to 7. This is given to us, right? What else? Eccentricity is equal to 4 by 3. Eccentricity is 4 by 3. And this will help us to find B somehow. What is eccentricity equal to? E is equal to C by A, which is equal to 4 by 3, implies C is equal to 4A by 3. Now A is already known, A is 7, so this becomes 28 by 3. Okay, C is 28 by 3, and we know that C square is equal to A square plus B square. That tells me that C square, which is 28 by 3 squared, is equal to A square, which is 49, plus B square. And from here I can find B square. Yes, I can find B square. What is this equal to? This is 28. 28 is actually 7 into 4. So this is 7 square, 4 square upon 3 square minus 49. I have written this 7 square separately because I want to take 49 common from here. 49 will come out common. What will remain is 16 minus 9, which is 7 upon 9 will remain. So what will this become? This is 7 times 5 is 350 minus 7, 343 upon 9. The value of b square is this, 343 upon 9. And a is already given. Therefore, equation of hyperbola will be x square by a square minus y square by b square, 343 upon 9 is equal to 1. Okay. Can I write this by simplifying a bit further? Yes. Maybe we can, this 9 will come over here and we can take LCM as 343, right? So I'll have to multiply this by 7 in the numerator. 7x square minus 9y square is equal to 343 is what I get for this particular question. This is the final answer in this 14th question, as you can see over here. In the 15th question, we have foci at 0, plus minus root 10 passing through 2, 3. Okay, foci at 0, plus minus root 10 implies foci lie on the y-axis. Yes. Okay, foci at this particular point. And what else? Since foci lie on these points along the y-axis, this point and this point, we can identify that foci lie along this. This will be the center and this will be the conjugate axis, right? So the x and y axis will be the transverse and conjugate axis interchangeably, right? And the equation will look like y square upon a square minus x square upon b square is equal to 1. This is what it will remain, right? And if this is the equation, the only thing that is required is a square and b square. With the help of foci, I can identify that c is equal to plus root 10. Therefore, c square is equal to 10, one thing. And passing through 2, 3 implies that's another condition that will be checked with respect to this. Okay, c square equal to 10 implies a square plus b square is equal to 10. That's one of the conditions. Condition number 1. The other condition is using that point 2, 3, which tells me, okay, 9 upon a square minus 4 upon b square is equal to 1. This is one equation. This is the other equation that we have for this question. And we have two equations. Can we solve the two equations to find a square and b square? Yes, we can find a square and b square with the help of these two equations. Let's see. Let's take the LCM over here. This is 9b square minus 4a square is equal to a square times b square. Okay, and use one of the values over here. Either we can substitute a square or we can substitute b square. So what do we want to substitute? Let's substitute a square is equal to 10 minus b square over here. 9b square is okay, minus 4 times this becomes 10 minus b square is equal to, b square is already there, 10 minus b square will be extra. So this is what I have over here. And let's try to rearrange this. 4b square, okay, and this is b power 4. Actually b power 4 will come over here, minus b power 4 will come over here, right? And this is 4b square plus 4b square, 10b square. 9 plus 4, 13 minus 10 is 3b square. And what else? You get minus 40 over here equals 0. This is what I am getting. 40 can be factorized as 8 and 5. And what you'll have is minus 8 and 5. So b square will be equal to minus 8 comma 5. Yes. Product of the roots, sum of the roots will be this, minus 3, and that's what you get. So b square equal to minus 8 will be rejected, implies b square is simply equal to 5. If b square equal to 5, then therefore a square is equal to 10 minus 5, which is again 5. Okay, once you have found a square and b square, now the equation is known. For equation of hyperbola will be y square upon a square minus x square upon b square equals 1, or y square minus x square equals 5 will be the required equation for this particular hyperbola, as you can see over here. That's the complete solution for this question. Foci at 0, plus minus root 10 passing through 2, 3. This is the standard hyperbola that we have written first of all, and on the basis of that we have found the values of a square and b square. Yes. And with this we come to the conclusion of this particular exercise from the chapter Conic sections. Till the next video, all the best.